Let's start. So here day 22. So we are covering two sessions on a same day, day 22. Okay. We are understanding data visualization, Matplotlib. The basic things we have seen. Now we have reached to the point styling the artist. What do you mean by artist? First question. So artist is that thing. Artist is that thing which is visible on your screen. We have seen the definition of artist over here. Can you see here? Artist, basically everything visible on the figure is an artist. Even the figure axis object, everything is artist. This includes the text, line 2D, everything. So how do you style the artist? Can you see something like this? So let's see this. Most of the plotting methods having the styling options. The artist's accessible either when a plotting method is called or from a setter on the artist. So in this plot below, we manually set the color, line width and line style of the artist created by plot. And we set the line style of the second line after the fact of set line style. Okay. So let's try to do that. So let me push this much also, or 21 underscore 22 here only. So here code, we already have imported required things, and let's create the figure and axis object. Figure axis is equals to plt dot subplots fixed size is equals to 10 and 3. Fixed size equals to 10 and 3. Now let's create the data. X is equals to np dot arrange and length of data 1, this guy, length of data 1. So if you see what is the length of data 1 over here is 100. In the function we have written, yeah, data 1, this one, 100, arrange 100. Okay. Or let's use same thing, len data 1. Then what? Ax dot plot x, here we can have np dot one function sum, cumulative sum of the elements of data 1, cumulative sum of the data elements 1, color is equals to blue, color is equals to what? Blue. Line width and line style. Line width, line style is equals to this. So what is np.comSum? See, return the cumulative sum of the elements along the specified axis. Cumulative sum. Notes, arithmetic is the modular when integer types and no error raised on the overflow. If you see this thing, so 1, 2, 3, 4, 5, 6, this is an array. So whenever you come to the function that you might not know, just open the official documentation. See the examples. What do you mean by comSum? Import numpy as np. np.array 1, 2, 3, 4, 5, 6. Array 1, 2, 3, 4, 5, 6. np.comSum a. And if you see 1, 1, 2 plus 1, 3, 3 plus 3, 6, right? 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21. Cumulative sum. You getting my point? Hello? And you can do it along with the axis, means row and the column. Cumulative sum. So that's what we have used. So whenever, if you don't understand any of the function in the document, because it is not necessary that, and it is not expected also that you should know everything. Absolutely not required. Right. So here np dot, so you might imagine what type of data it is going to return. Color blue, this thing. Then what we can say, ax dot plot, just run it. Can you see? So this is the dash, it is printing this dash, and you are getting data visualization like this. If we weren't using, you say what kind of data you get over the x-axis and over the y-axis. Your line width you can adjust, say 1 if you run the line width as 1, more thinner if you say 5, more thicker like this. If you say this single dash, see what happens? Attached thing, you will get single dash. Can you write hash over here? Run it. Error. Hash cannot be written. Double dash means dotted line. Can we write dot over here? Single dot. Run it. Error. Double dot. Error. So there are different line styles available. Can you see? There is, learn from the error. Double dot is not the valid value for ls line style. Supported values are single dash, double dash, dash and dot, colon, none, empty, or here is the white space, empty, solid, dashed, dashed dot, dotted. So here you can write dotted also, something like this. Dotted. Here you can say dashed also, which will look like this, dashed. You can write, and this also, see, something like this, dash and dot, dash dot, dash dot, dash dot, dash dot, dash dot, dash dot, like this. You can give double dash also, dashed. Correct? Any questions? So this is the one plot we have printed. Now second plot, L is equals to ax dot plot, come some data to, cumulative sum data to orange, line width is equals to 2. Run it. Can you see this thing? and we can set the line style separately. Remember that this is the fig object. L is nothing but what? The fig object. So here we can say L dot set line style colon. So it is looking like this. Each data point would be represented by this colon. Correct? Fig size we have given. So this is the fig size we are having. So X is from the 100, 0 to 100 that you are getting. Cumulative sum, we understood what is the cumulative sum. This is the visualization of X, which is ranging from 0 to 100, and the cumulative sum, which is ranging from -5 to 10. A cumulative sum which is ranging from -5 to 10. So X and the Y. So every time you can write, if you want to explicitly write it, you can write in this way also, X and Y. Here you can write Y. So Y is always the function of X. Y is always the function of X. Right? So that's what we have done over here. X and Y you are printing. Here also you are printing X. Here you can say Y1. This would be the Y1. Here you can say Y2 is equals to np dot come sum data 2 Y2 and run it. X Y1 X Y1 X Y2. Correct? Colors, we can specify the colors also. Scatter plot. So here we have done the line plot. Here it's a scatter plot. We are going to see this thing in EDA section. Which section? EDA. Exploratory data analysis. At that time, heavily we are going to use the matplotlib. We would be using matplotlib heavily. Okay, let's change the colors. Let's do the scatter plot. These are different plots. They have a meaning. So this is a line diagram. Then there is a scatter plot. What is a scatter plot? It's not a concern of the matplotlib. It is the concern of the statistics, and we will see that shortly. So you can say fig and AX here, fig and AX, PLT dot subplots, PLT dot subplots, PLT dot subplots, fig size, ten3, fig size 10.3, AX dot scatter plot, AX dot scatter plot, data 1, data 2, data 1, data 2, marker O, and just run it. So this is the scatter plot. How data is scattered along the numbers, right? Then we can say the S is equals to 50. S is equals to what? 50, a little bit increased if you see. S is equals to 50. face color is C0, color we are giving, it's a predefined color, face color C0, edge color K, edge color is equals to K. And if you run it, can you see little background we can have? Can you see this is the red, and edge color you can say black. Here you can say blue also, right? Yellow, yellow dots, and round this thing. Any question, guys? Hello? So let's try to give 100, little bit bigger, right? 150, it is bigger little bit, but keep it default, so it will not go, just default is always okay. Okay, so the scatter plot means what? We are going to see that here immediately you can say that the data samples are accumulated in this region minus 1.5 to the 1.0. Most of the data point are ranging from minus 1.0 or somewhere over here to this point. Yes or no? That's why visual, you know what is the data 1 and data 2. These are the random numbers. Data 1 and the data 2 are the random numbers. But by looking at the data 1 and data 2, you cannot tell exactly. I can print the data 1 here, print it. So what you will understand from here? Nothing. Why visualization is important? You will not understand where is the data, what is the data 1, what values are occurring, right? That values you can visualize over here. So these are the 100 values. So these are the 100 points. And you can clearly say that where exactly are the random numbers. So this is the cluster over here. Most of the data points are over here. So from here also you can predict that this is the rate of the failure. So whenever your pump is ranging between 1.5 to 1.0 is a normal thing. If if your pump temperature is ranging between 1.5 to minus 1.5 to 1.5, this is okay. Most of the data points are over here, and these between 1.5 to 2.0, these things are the outliers. So you need to figure it out, what is this? You getting my point? So why 1.5 and the y is 3? What is this exactly? What happened over? You will ask the question to your client. What you have done over here? So whenever your pump RPM are 3000, something is happening, right? These are the normal. We can clearly, your machine learning model also will tell that if you draw any point over here, your ML model will tell that, well, boss, this is the normal thing. But if you draw point over here, ML model will think that, well, this is the unusual, because rest of the data, I told you machine learning in one, what you can say, in one thing, how machine learning model works, where exactly your data point is between this normal range or outside the normal range. That's what your prediction is. Hello? You understood, right? What I mean to say. Any question, guys?
No questions, but it will take time to understand.
Yes, it will take time. So this data 1, which looks like this, but you cannot say anything about data 1 over here. You can't talk anything about this data 1. But the minute you plotted the data 1, you got to know the clear idea, right? Okay. So we have seen how exactly you will change the color and the edge color. Edge color is nothing but, in our case, this border. Edge color is this border. Okay. So line width, line styles, and the marker sizes. Let's do this thing. We have 4 different types of data available. Pig and AX is equals to PLT dot subplots. PLT dot subplot. Pig size. Pig size is equals to 10 and 3. 10 and 3. Now let's plot our all the data sets. AX dot plot data 1, data 1. Let's have O, label is equals to data 1. Then AX dot after the O what D, label data 2, data 2, data 3, V, data 4, S, here you can say data 4, AX dot legend, run it. See here, a dot is the data thing, D means diamond is this thing, V means triangle, lower triangle, and S means square. Can you see the shapes? And here you can clearly see how your points are arranged. Colors it has created automatically, but we can give color on our own. The face color, here you can give face color red. So you need to be good at aesthetics now. Face color yellow. It is internally automatically checking face color blue. Cyan. Okay. Face color oh okay, got it. Face color is not there for the line plot. marker color. Marker color. Run it. Marker base color. Yeah. Can you see that? So you can see the different data over here. Line width and line styles. Axis labels. Axis labels. Axis labels, this over here and this over here. Axis labels. Okay. Now let's try to plot this thing. Now this histogram is there. Again, what is a histogram? You'll get to know in the next chapter, EDA, exploratory data analysis. Okay, but matplotlib is nothing but what? Printing. Matplotlib is nothing but what? The printing. Now how to do that? Let's see that. Labeling the plots, we are understanding this. Labeling the plots. So styling the artists we have seen. Next thing, labeling the plots. Okay, so let's create a tuple over here. Mu, mu, sigma, 115, 15. Okay, then x is equals to mu plus sigma into np dot random. How many random number you need? 1000 random numbers. Random dot rand n. 1000 numbers we would be needing. Sorry, 10,000 numbers we would be needing. Let's try to print this equation. Right? So fig ax subplot 10 and 3, and here just run this. Here you'll get the histogram, a normal distribution, probability. If you see, the data is normally distributed along the mean. If you got the mean, data is equally distributed. So this thing is called as normal distribution. We'll see that in the next chapter. Now here, what we need to do, we need to give some labels. Can you see here? Here are the labels. Here are the labels. So let's name the x and y axis. These two things. Let's name the x and y axis first. Let's do that. Let's name it. Okay, then this title, let's run it and see what happens after running this. Can you see here, length in cm and the probability. Set the title. Set the title. We need to set the title. Title means graph title you will get. Run it. Can you see this title? Then text. On the particular location we need to give this text. On the graph you need to give this text on the particular location. If you see 75.25, if you say 100, run it. Can you see this location is nothing but what? The 75. Exactly where you want to print this. And 0.25 means from this. And value are, so it is nothing but these values we need to print mu115 sigma. So it is for the, it is for this symbol, this has been used, mu, and the sigma, this is the notion for the sigma they have used, 15 and the dollar, something like this. Okay, axis, here you can say axis. If you see this axis and run, just run it. Axis 55, 175. So this is an array 55, 175 and 003. And the grid true, ax dot. So if you see this thing, y minimum 55, minimum y we have set 55, maximum, sorry, this is a minimum x, minimum x is 55, maximum x is 175, maximum x is 175, minimum y is 0, here minimum y is 0, and maximum y is point not 30. Can you see maximum y is point not 30? So here minimum x is 55, maximum x is 175, minimum y is 0, maximum y is this 30. And the grid true, once you make the grid true, run it, so you will see the grid and other things.
And if we doesn't set the axis, then how will it plot?
Automatically, it will do automatically. In the early stages we didn't specify any axis, it will do it automatically. Whatever the numbers, can you see, it will decide it from your data, automatically it will decide it from the data. But whenever you use your visualize for the first time using the other plots, you will get to know what are the values, and from that you need to decide, you do the statistics, minimum and the maximum. So you need to set min and max accordingly. Clear?
Yes.
Any other queries?
I'm not curious, but I think we will require some time to get
Sure. So shall I
things.
continue or shall I stop?
I think we can stop today.
Okay,
Can you
fine.
explain simple assignments for network to like
Yeah,
we can practice some of them?
sure. So first, what you can do is that NumPy array functions we are having, right? NumPy array functions. NumPy is creating the data. We have seen the different ways to create the NumPy data. Now you need to plot all that things. You getting my point? Actual assignments you will get after the EDA on this part, because presently if you just follow along with this thing, that would be okay, right? So one more section of this is remaining, that is about the next topic I was about to cover, is the pandas, right? And then I can give you some homework. So we have this data after EDA. Actually that would be the great time, because if I want to say just add the box plot, tell me the how many outliers are there, right? So that will happen only after the EDA. But presently you need any homework, I request you to first thing, whatever array creation functions we have seen, try to plot those array creation functions, right? And just follow along with this thing. So whatever things they have done over here, just type every code over here. So these things, first complete these things. Okay. After the EDA, you will get a lot of work for the homework. So what about, just a minute, let me stop the recording.